بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the final exam of Math 113 Term 221. Let us have a look to the exam and try to solve it together. So the first question, evaluate the following integrals. So how to find the integral of tan square x? Well, I don't have a formula for tan square, but I know that tan square x plus 1 is equal to secant square x. And I know the integral of secant square x, it is tan x, because the derivative of tan is secant square. So I will write tan square as secant square x minus 1. And now the integral of secant square is tan x, and the integral of negative 1 is negative x plus c, and that would be the answer of this integral. The second integral, integral of x times cosine pi x dx. Well, I have product, and x times cosine, x times sine, x times e. We know always we use by parts, integration by parts. So I take u as x, du would be dx, and I take dv equals to cosine pi x dx. And then I find the integral of dv, it would be, and the integral of cosine is sine, because the derivative of sine is cosine. But I have pi x inside, so I need to divide by the derivative of pi x, which is pi. And now, if I call this integral I would be equal to u times v, so x sine pi x over pi minus integral b du, v minus d du. So I'll have 1 over pi, I can take it outside, and integral sine pi x dx. Well, integral of sine pi x is negative cosine pi x over pi. Okay. So the final answer would be x sine pi x over pi minus 1 over pi times integral of sine is negative cosine. So this would be positive cosine pi x over pi. So I'll have pi square here, and then plus c, and that would be the final answer. Integral of x square over 16 minus x square. Well, square root of 16 minus x square, when we have square root of a square minus x square, we know that we choose x equals to a sine theta. A here is square root of 16, which is 4. So x is 4 sine theta. And then we find dx would be 4 times the derivative of sine, which is cosine d theta. And then we change the integral from x to theta. So I'll call it I also. I need to change this radical. So square root of 16 minus x squared would be square root of 16 minus x squared would be 16 sine square theta. And I can take 16 as a common factor. And I'll have 1 minus sine square. or I can just write it cosine square. And the root of 16 square root is 4, and square root of cosine square is absolute value of cosine, but inside the domain, the chosen domain of this substitution, I'll get 4 cosine theta. So the integral I would be, what is x squared? X 4 sine theta, so x squared is 16 sine squared theta. The square root is equal to 4 cosine theta, and dx, I'm looking here, and I'm changing this integral from x to theta. So dx is, I found it here, it is 4 cosine theta d theta. So you can cancel 4 with 4, cosine with cosine, and I can take 16 outside, and I'll have integral sine squared. We know how to deal with sine square. We need to write it using a formula as 1 minus cosine 2 theta over 2. This is a formula for sine square theta. I can take this 2 outside, so I'll have 16 over 2, which is 8. And then the integral of 1 is theta, and the integral of cosine is sine. But I'll have to divide by the derivative of 2 theta, which is 2 plus c. So that's the answer. But now I need to go back from theta to x. So the relation between theta and x is given here. From here, I can write sine theta as x over 4. If you divide by 4, both sides. And then I can draw a triangle for the angle theta. I know sine theta. Sine theta is the opposite over the hypotenuse. And then I can find this side from Pythagorean theorem. It is the largest, the hypotenuse square, 16 minus x squared, the length of this side. And always this root should be the root in the question, if everything is going fine with you. Then now I can write final answer, 8 theta. But what is theta? Well, sine theta is x over 4, so theta would be sine inverse x over 4 minus 8 over 2 is 4. And what is sine 2 theta? Well, you have to remember that sine 2 theta is 2 times sine theta cosine theta. There is a formula for sine 2 theta. So there will be a 2 and there is a 4. So I'll have the 8 back. Okay. And then I'll have sine theta cosine theta. Well, sine theta is x over 4. And cosine theta now is the adjacent over the hypotenuse. So it is 16 square root of 16 minus x squared over the hypotenuse, which is 4 plus c. You can leave it like this, or you can write it 8 sine inverse x over 4 minus 8 over 4 is 2, and 2 over 4 is 2. So in fact, I have x over 2 square root of 16 minus x squared plus c. And this would be the final answer. Determine whether the integral is convergent or divergent. If it is convergent, find its value. So convergent, divergent, he's talking about an improper integral. We have two types, infinity, when we have infinity at one of the limits or both, but there is no. So this should be the second type, in which the function is not continuous on this interval from 1 to 9. If you look to the denominator, the denominator is not defined at 1. So we have a discontinuity at 1. So the integral from 1 to 9 of 1 over cube root of x minus 1 dx is an improper integral. And by definition, it is equal to the limit when t approaches 1 from the right, because 1 and 9, you can approach 1 from the right. I replace 1 by t, 2, 9, and then 1 over cube root of x minus 1 dx. Well, first we need to evaluate this integral. Well, this is x minus 1 to the power 1 over 3, and when we take it up, it would be to the power negative 1 over 3. So the integral would be x minus 1 to the power, I add 1. So negative 1 over 3 plus 3 over 3, it would be 2 over 3 over 2 over 3, or times 3 over 2. So I'll have the limit when t approaches 1 from the right of, I can take 3 over 2 outside, and I have x minus 1 to the power 2 over 3 from t to 9. And this would be equal to, I have 3 over 2 outside, then replace x by 9. 9 minus 1 is 8. 8 to the power 2 over 3 minus, now replace x by t. So t minus 1 to the power 2 over 3. Now, when I replace t by 1, this would be 1 minus 1, it would be 0. So the answer would be 3 over 2 times 8 to the power 2 over 3. And 8 to the power 2 over 3 is 4 by the calculator. So 4 divided by 2 is 2, and the final answer is 6. So find its value, the value of 6, convergent or divergent. Convergent. So I can say integral converges to 6. That would be the final answer. Determine whether this series is convergent or divergent. If it is convergent, find its sum. Well, if he asks about the sum, it must be a geometric series or telescoping sum. It's clear that this must be a geometric series. A geometric series, the form for geometric series, when n from 1 to infinity of a r raised to the power n minus 1. That's the form. I need to find a and r. So I need to write the series in this form. This is one way. So I have 6 to the power n minus 1. That's good. But I have e to the power 2n. I need it to be n minus 1. So either you try to write this series on this form, in this form, or simply you can find the first 3 terms of this series. So when you replace n by 1, the series would be equal to what? 6 to the power 0, which is 1, over e to the power 2. So 1 over e squared, this is the first term of the series. The second term, replace n by 2. So I'll have e to the power 2 times 2, that's 4. And 6 to the power 2 minus 1, so 1, that's 6. Plus the third term, when n is 3, I'll have in the denominator e to the power 2 times 3, that's 6. And 6 to the power 3 minus 1, that's 6 squared, plus, and so on. Now, this is a geometric series with a equals 1 over e squared. And how to find r? I divide any term by the previous term. So I can divide 6 squared over e to the power 6 by 6 over e to the power 4. So multiply by the reciprocal, which is e to the power 4 over 6. 6 squared over 6, I'll have 6. And e4, e6 down, I'll have e squared below. So 6 over e squared is the common ratio, r. Okay? If you multiply this by 6 over e squared, you get this one. Multiply by 6 over e squared, you get this one, and so on. Now, r, is it less than 1 or greater than 1? You can check that e squared is more than 6. So this is less than 1. So the series is a geometric series with r less than 1. So it is convergent. So the series is convergent. How to find the sum? Well, the sum is a, the definition, a over 1 minus r. So what is a? The first term, 1 over e squared over 1 minus r. What is r? 6 over e squared. To get rid of e squared, I can multiply by e squared over e squared. So I'll have 1 in the numerator, and e squared times 1 is e squared, and here e squared will be cancelled, and I'll have 6. So this would be the sum of this geometric series. Determine whether the series is convergent or divergent. Explain your answer. Okay. I have here 1 over e minus n plus 4. Well, e to the power negative n, what do we know about e to the power negative n? It is a geometric series, but I have here plus 4. Let me find the limit of an. Check what is the limit of an. This is an when n approaches infinity. When n approaches infinity, e to the power negative infinity is 0. So the limit is 1 over 4. Okay, it is not equal to 0. So series is divergent by test for divergence, or you can call it divergence test. So once you find the limit not equal to 0 immediately, the series is divergent. While here I have n cube over n to the power 4. So this is an, and I can bn, I can take the highest power in the numerator, which is n cube, over the highest power in the denominator, n to the power 4, and then n cube over n to the power 4 would be equal to 1 over n, okay, when you cancel. So, or when you subtract the powers. So Pn, what do we know about summation 1 over n? Well, summation 1 over n is the harmonic series. The harmonic series. And the harmonic series is divergent. It is also, it is a p series with n equals to 1. So you can say also that it is a p series with p equals to 1. So it is divergent. So we know that summation bn is divergent. Now, can we write n cube over n to the power 4 plus 4 greater than 1 over n? Because we need to, it has to be greater than if we want to use the direct comparison test. Well, n to the power 4 plus 4, I have two n's here. I'll just consider the limit comparison test. In the limit comparison test, I need to find limit an over bn when n goes to infinity, and this limit has to be greater than 0. So this is n cube over n4 plus 4 divided by Vn or multiplied by the reciprocal of Vn, which is n. So this would be n to the power 4. So to find the limit, we usually take the highest power. The highest power would be n to the power 4 up and n to the power 4 down. When you cancel, you will get 1. And now, what is the limit of 1? It is 1, and it's greater than 0. So, by limit comparison test, series diverges, or the series is divergent. All right, the next one. I have n plus 1 to the power n. Whenever I have power n, I will think of the root test. And in the root test, I need to find the limit of nth root of absolute value of an when n goes to infinity. So this is an, and it's positive, so absolute value would be positive. But what would be the nth root of an? Well, the nth root of 1 is just 1, and n will cancel with n, and the nth root of n plus 1 to the power n would be just n plus 1. So this is the nth root of an. So now I need to find the limit of 1 over n plus 1 when n approaches infinity. And infinity plus 1 is infinity. 1 over infinity is 0. 0 is less than 1. If this limit is less than 1, then the series is absolutely convergent by root test. I have factorial and powers, so I'll use the ratio test. In the ratio test, I need to find the limit of absolute value an plus 1 over an when n goes to infinity. So this is an, this is an. What is an plus 1? You replace n by n plus 1. So I'll have n plus 1 to the power 100, and I'll have 100 to the power n plus 1. And in the denominator, I'll have n plus 1 factorial. And let us find now the absolute value of an plus 1 over an. Well, I should divide n plus 1 by an, or multiply by the reciprocal of an. So it would be n factorial in the numerator, and here I'll have n to the power 100 times 100 to the power. All the variables are positive, so there is no need for the absolute value. Now notice I have n plus 1 over n to the power 100. Okay, this is, I cannot here simplify. But I have 100 to the power n plus 1 over 100 to the power n. I can subtract the powers because I have the same base. N plus 1 minus n is just 1. So I'll get 100 in the numerator. For the factorial, I have n plus 1 factorial and n factorial. I know that n plus 1 factorial is equal to n plus 1 times n factorial. So I can cancel n factorial with n factorial, and I'll have n plus 1 in the denominator. So this is an plus 1 over an after simplifying. Now I need to find the limit. So what is the limit? I'll find the limit of this quantity times the limit of this quantity. Okay, you can distribute the limits when you have products. So the first one, I can take the limit inside the power. What is the limit of n plus 1 over n? take the highest power, n over n, so 1. So the limit is 1, 1 to the power 100. And the limit here, if n goes to infinity, 100 over infinity. Infinity plus 1 is infinity, 100 over infinity is 0. 1 to the power 100 is 1, 1 times 0 is 0. It is less than 1. So by ratio test, okay, by ratio test, series is absolutely convergent. Find the average value of the function. Well, the definition of the average value, if average, we write it like this, okay, equals integral, before the integral, 1 over b minus a, integral from a to b, f of x. That's the definition of the average value. So it would be 1 over, b here is 4, a is 1, 4 minus 1 is 3, from 1 to 4, x e x squared dx. Now we need to find the integral of x e x squared. So I'll take u equals to x squared. Then du would be 2x dx. And when x is 1, u would be u equals 1 square, which is 1. And when x is 4, u would be 4 square, which is 60. So this would be 1 over 3 times the integral of integral from 1 to 16 e to the power u, okay, because x squared is u. But for du, I need 2x dx. I have only x, so I will put 2, and I write du, and I will divide by 2 outside. And 2 times 3, I'll have 6. So I'll have 1 over 6. The integral of eu is just eu from 1 to 16, and the final answer will be e to the power 16 minus e to the power 1 over 6. This would be the average value of the function. Find the radius of convergence and interval of convergence of this power series. All right, we use the ratio test. We have an and an plus 1. I replace n by n plus 1. And now I find an plus 1 over an. So it's negative 4 to the power n plus 1 times the reciprocal of an. Okay, I have negative 4 to the power n plus 1, negative 4 to the power n, the same base, subtract the powers, n plus 1 minus n is 1. So I have negative 4 to the power 1. And x to the power n plus 1 over x to the power n, subtract the powers. So I'll have x to the power 1. And then I have square root of n over square root of n plus 1. Now the absolute value of an plus 1 over an would be 4x, absolute value of x, times square root of n over square root of n plus 1. If you take the absolute value, the negative will disappear, and you have to write absolute value of x because x could be positive or negative. Now, if you take the limit for this quantity when n goes to infinity, you take the highest power up, the highest power down, you will have square root of n over square root of n, that's 1. So this will go to 1. So the limit would be 4 times absolute value of x. Well, the series would be absolutely convergent according to the ratio test if 4 times absolute value of x is less than 1, which means that absolute value of x is less than 1 over 4. So R, the radius of convergence, is 1 over 4, this number. And now, for the interval of convergence, I'll have x between -1 over 4 and 1 over 4. That's the solution of this inequality, absolute value inequality. I don't know what happens when x is -1 over 4 or 1 over 4. The test fails, the ratio test fails. So here I can say by ratio test. Okay, so let us consider the case when x is -1 over 4. Here, the ratio test will give you 1. The limit would be 1. So the test fails. So let us go to the original inequality, original series, this one, and replace x by -1 over 4. So I have -4 to the power n, and instead of x, I have -1 over 4 to the power n, and below I have square root of n. Well, here I can write it -1. Okay, let me take the negative with the 4. So I'll have -4 to the power n times 1 to the power n over -4 to the power n, and here square root of n. So I can cancel these two, and I'll have 1 over square root of n. So this would be the series when x equals -1 over 4. And this is a divergent P series because P is 1 over 2 less than 1. So it's divergent P series. So when x is -1 over 4, the series is divergent. But what happens when x is 1 over 4? In this case, I'll have -4 to the power n over square root of n, and here there is no negative. So I'll have 1 over 4 to the power n. And this one I can write it -1 to the power n times 4 to the power n, which cancels with 4 to the power n. So I'll have -1 to the power n over square root of n. This would be the series in this case. And this is an alternating series in which Bn is 1 over square root of n. When n goes to infinity, it goes to 0. And 1 over square root of n plus 1 is less than 1 over square root of n, because square root of n plus 1 is greater than square root of n. So decreasing Bn is decreasing. So the two conditions for the alternating series are met. Then by alternating series test, this series summation n1 is convergent. So when x is 1 over 4, the series is convergent. When x is -1 over 4, the series is divergent. So the interval of convergence would be, it's supposed to be from -1 over 4 to 1 over 4. 1 over 4, it is convergent, so I close it. -1 over 4 divergent, so I open it. And this would be the interval of convergence. Sketch the region bounded by these two curves and find its area. So y equals x squared minus 6. What is the graph of y equals x squared minus 6. That's just a parabola opens upwards, taking 6 units down. So 1, 2, 3, 4, 5, 6. So it will go like this. And here, negative x squared plus 12. So negative x squared is this parabola, opens up downwards. You take it 12 units up to here. So it will go like this. So these two parabolas will meet somewhere. And I need to find the intersection points between these two parabolas. So I put y equals to y, or 12 minus x squared equals x squared minus 6. And I solve this equation. If I bring x squared here, I'll have 2x squared. And if I take 6 to the other side, 12 plus 6 would be 18. This means that x squared is 9, which means that x is plus or minus 3. So they meet at 3 when x is 3 and when x is negative 3. And if you put here 3, you'll have 9. 9 minus 6 is 3. So in fact, they meet at this point. 3, 3, and negative 3, 3. So you can sketch the graph, this parabola, and of this parabola, they meet at this point. And now this is the area between them. We need to find the area between them. So it's clear that this parabola, which is 12 minus x squared, is above x squared minus 6. So for the area, we use here a rectangle, vertical rectangle. And when you use a vertical rectangle, the width of the rectangle is dx, part of x. So the integral would be with respect to x. X from where to where? From negative 3 to 3. That's the region. And which curve is above? So we have 12 minus x squared minus the other curve, which is x squared minus 6 dx. So this integral will give you the area between the two parabolas. So I'll have from negative 3 to 3, negative x squared minus x squared is negative 2x squared, and 12 plus 6 is 18. The integral would be x cubed over 3 plus 18x from negative 3 to 3. So I'll have, if I replace x by 3, 27 over 3, that's 9 times negative 2, that's negative 18, plus 3 times 18, that's 54, minus. Now I replace by negative 3, I'll have negative 27 over 3, that's negative 9 times negative 2, that's 18, plus, replacing by negative 3, I'll have negative 3 times 18, so that's negative 54. So I'll have negative 18 minus negative 18, that's negative 36, and positive 54 plus 54, so I'll have 108, and the final answer would be 108 minus 36, which is 72. So that's the area between the two curves. Find the exact surface area of the region obtained by rotating the curve about the x-axis. Well, the formula for the surface area when we rotate about the x-axis is integral 2 pi y times ds. And ds is the arc length, and you can choose it to be with respect to y or to x according to the question. Since x here is given, the limits of x is given, so I'll choose to write it with respect to x. So here I have 1 plus dy by dx or y prime square. Okay, and from negative to 2. So I can take 2 pi outside. Now I have y here, but the integral is with respect to x, so I need to write y, the definition of y, which is 4 minus x squared. And let us here work a little. Let us find y prime. This is y. What is the derivative of the root? 1 over 2 times the root times the derivative of what is inside the root, which is negative 2x. So you can cancel 2 with 2, and y prime would be negative x over square root of 4 minus x squared. I need y prime square. It would be x squared. The negative will disappear with the squaring, and this would be 4 minus x squared. The root also will disappear when we square. So now what is 1 plus y prime square? Okay, I'm finding this quantity. I need to add these two fractions. You use just the addition, how to add two fractions. So 4 minus x squared times 1 plus x squared times 1. X squared cancels with x squared, and the answer will be this one. So in fact, here, the square root of this quantity now would be the square root of 4, which is 2, over the square root of 4 minus x squared dx. And now you can cancel this root with this root, and you will have 2 pi times integral from negative 2 to dx. You can take 2 outside, so you'll have 4 pi, and integral dx is x from negative 2 to 2, so you'll have 2 minus 2, or 4 times 4, so it is 16 pi. So the answer is 16 pi. That's the surface area. And this was the last question. And I hope that you enjoyed watching this video with me. See you in next videos, inshallah.